Guys, so today I'm going to be filming a solution guide for a question in Energizing Physics lesson 3.3. So in this question we have Finn pushing a box, and we are given this free body diagram, and we're asked to find several unknowns. So let's get started. So part A asks for KE1. So we know the equation for KE is 1/2 mv squared. And we are given that the initial mass is 20 kilograms and the velocity is 2 meters per second. So that's equal to 40 joules. Part B is looking for the work of the floor, and we know that work is equal to force dot product of displacement, and we know that the displacement is in the horizontal axis, whereas the force of the floor is in the vertical axis. So since they're not parallel, this means that the work is 0. Or more, that they are directly perpendicular, so that means there's no parallel component. Part C is looking for the work of Finn, and work of Finn is equal to the force of Finn dot displacement, which just means the multiplication of the horizontal component of Finn's force and the direction that the box moves. So we know that the displacement is 3 meters, and we know that from the free body diagram that the horizontal component of Finn's force is 120 newtons. So it's 3 times 120, which is equal to 360 joules. And it's positive because he's doing positive work, i.e. the force and the displacement is in the same direction. Now, part D is looking for KE2, and we're given both the mass, which is still 20 kilograms, and the final velocity, which is 4 meters per second, and this is equal to 160 joules. Part E is looking for the work of friction. So this is only slightly trickier. We know that E1 plus work is equal to E2. So we had already found KE1 in part A. So KE1 plus work of Finn plus work of friction is equal to KE2, which we solved for in part D. So let's just plug in the numbers that we found already. KE1 is 40 joules plus the work of Finn, which we found in part C, 360 joules, plus work of friction is equal to 160 joules. So work of friction is equal to 160 minus 400, which is equal to negative 240 joules. And now for part F, we're looking for the force of friction, and we know that work is equal to force times displacement. So that means that force is equal to work divided by displacement, which is equal to negative 240, which we found in part E, divided by 3. So we know the force of friction is equal to negative 80 newtons.